welcome you all in this course on mechanical measurement systems. Today we shall start with the transducers. Topics to be covered today are, first I will give you introduction of the transducers. Then there are certain mechanical detectors which are used in transducers. Electrical transducers, then we will do classification of transducers, selection of transducers, and we will discuss different type of transducers. So to begin with, introduction and definition of transducers. Now transducer is a device which is used for converting one form of energy into another form of energy. But that's a very broad definition of transducers. A certain amount of energy is giving. Suppose some force is applied and some displacement is taking place, right? So this energy due to this force and displacement Fx is going to the transducer, and then it is converting in different type of energy, or normally nowadays the output of the transducers are in the form of electrical signals. Electrical signals may be in the form of voltage or in the form of current. Now the output in voltage, normally it is in the range of 0 to 10 volt DC normally. In some of the transducers it is 0 to 5 volt DC or plus minus 5 volt DC. Or the output in the transducers is in the range of 4 to 20 milliamperes. Even when the signal has to be transmitted for a far off distance, suppose we are acquiring data in this room and data has to be transmitted somewhere 100 meters away or 50 meters away from this room. In that case, normally this current type of output is preferred. Because if we go for the voltage type of output, voltage drop may take place in wire also, and that will change the actual output. So nowadays it is also defined, transducers are also defined in a device which converts, which takes certain amount of input, and the input is converted into the electrical signals, right? And normally electrical signals are in the form of voltage and current, and signals are normally in digital form, or after transmission they are converting into the digital form, because the data acquisition at the time of acquiring the data, because all these signals will be going to a data acquisition system. And in a data acquisition system, the signals are stored in a digital form, so that you can transfer those signals to other systems in the digital form, taking these data in a pen drive or CD or in a floppy. So now transducers may contain a primary sensing element also, or they may not contain a primary sensing element. Second thing is, sometimes the output of the transducer is very weak. It is feeble output. So this output has to be amplified or increased. So for the amplification purpose, if it is an electrical signal, we can use amplifiers. Amplifiers can be very well used, and feeble signal can be converted into a powerful signal. Mechanical signals also can be amplified. For example, there is a change in the level. You are just connecting one phenomena with the change of the level of the water. Now this change in level of the water dx can be enhanced by just putting this water in connecting a tube, right? So whatever change is taking place here, but that will be in the vertical direction. So whatever change in volume is there, not in dx, whatever change in the volume is there, here you can very well or accurately measure the volume. So that is another way of enhancing the output signal third way can be like you can use lever. Theta, suppose there is a displacement theta and you are measuring theta with certain displacement tx. So this principle you can always enhance this dx to dy if this L2 is greater than L1. So amplification of signal is also important. It is often being done in the case of transducer. So first of all, the measure end, in the contact of the measure end comes the transducer itself. In most of the cases, it is transducer which comes into the contact of measure end. For example, thermocouple. For example, pressure gauge, right? So pressure gauge is a transducer, right, which convert pressure into the deflection of the needle by a certain angle. So it is a sort of a transducer. Thermocouple is a transducer because it converts temperature into the EMF. And these transducers, they also come into contact with the measure end. And in the process of measurement, certain amount of energy is drawn from the measure end. This I have already explained earlier. In the process of measurement, certain amount of energy is drawn from the measure end. So this energy has to be minimum. For well-designed transducers, actually transducer should not draw any energy from the measure end, but without withdrawing energy, the measurement process is not possible. So transducer should draw, I mean, a good well-designed transducer should draw minimum energy from the measure end. And nowadays, most of the signals or output from the transducer is in the form of electrical signals, and electrical signals are normally voltage, are in the form of, either in the form of voltage or in the form of current. Now, while we are selecting a transducer, normally I am talking about the mechanical transducers. In mechanical transducers, the output is normally in the form of motion. The output of the transducer is normally in the form of motion. It may be a linear motion or it may be an angular motion. Now, the certain things are to be kept in mind while choosing a transducer for a mechanical system. That is magnitude of the motion. What is the magnitude of the motion? Because once you know the magnitude of the motion, you can identify the quantity of error also in the measurement, right? So definitely if the magnitude is not much, the amplifiers are used to amplify the motion so that error in the measurement is reduced. And while going for the transducer, we should know, obviously we should know for input-output relationship. Of the input-output relationship is QO upon QI, either for a transient input or for a cyclic input. So output and the input relation has to be known while going for the transducer. Now static, now again it follows by static and dynamic characteristics of the transducer. Especially when there is a time variant signal. When there is a time variant signal, the dynamic characteristics becomes very important. And because nowadays we have digital storage system, so storage is not a problem for us. Earlier, storage was a problem. I mean, there were many other mechanical devices where the recorder type of devices were used, chart recorder type of devices were used for the storage of data. But nowadays, we have digital storage system, and that is very convenient for storage of data. And very easily, we can go for, let us say, 100 kilosamples per second. Such type magnitude of data acquisition we can go for if we have appropriate data acquisition system. Now, attachment type and proxy type. Some of the transducers do not come in contact with the measure end. physically they are not in contact with the measurement. So such type of transducers are known as proximity sensors or proxy type of transducers. And the third one is, and the last one is active transducer and passive transducer. And passive. Now, passive transducers are those transducers which do not require any external source of energy, right? Simply you put the transducers, no power input is required. For example, thermocouples. Thermocouples are one of those such transducers which do not require any external source of energy. Simply one end of thermocouple you can put on the measurement, and other end either you connect to the data acquisition. It depends upon the type of data acquisition system you are using. If you are using a modern data acquisition system, immediately the wires can go to the data acquisition system. If you are using the voltmeter, in that case, this side has to be in 0 degree centigrade and voltmeter will be fixed somewhere here, right? But nowhere it is drawing energy from external. It is a standalone system. It is not drawing any energy from the outside source. Simply one end is at higher temperature, let us say 100 degree centigrade. This is melting ice at 0 degree centigrade, melting ice of distilled water. Now EMF is generated, we will measure the EMF. There are calibration charts. For a particular EMF, we can find the value of temperature. And we can see whether it is 100 degree or 99 degree or 101 degree. But no external source of energy is required. However, in the case of, let us say, pressure transducers, in pressure transducers, for measuring the pressure, external source of energy is required. Normally, the source of energy varies from 12 to 24 volt DC. Normally, it is not necessarily, but normally it varies from 12 to 24 DC supply. And this excitation voltage, what it does, it magnifies it activates the primary sensing element, and at the same time it magnifies the output of the transducer. So there are two types of transducers, active transducer and passive transducer. So passive transducer does not take any source of external energy. Active transducers, they do take external source of energy, right? So that is another way of classification of the transducer, and we have to choose for a particular application which type of transducer will be suitable. Now, there are certain mechanical detectors. For example, for displacement, there is a detector Prof ring. Prof ring is used for measurement of force. So input signal is force, but we cannot see force. Force cannot be seen. So first of all, the function of the transducer is to give the output in to change the phenomena, or to give the output in a measurable quantity. Force we cannot measure, we can determine force, mass into acceleration, right? For measuring the force, a transducer is used, and this force will be converted into the displacement, right? So how we can do that? There are several techniques. Simplest one, you take one cantilever and just apply force here, whatever the displacement is there, delta. And delta and force relationship is also known to us, that is delta is equal to 1 upon 3 EI. Sorry. 1 upon 3 F over EI. So delta is a function of F. That is one way. I mean, there can be several ways. I mean, and the most popular or established way of measuring force is probing ring, but in the probing ring, we can go for a small amount or medium amount of force, small or medium forces. For very large force, it is not recommended. And probing ring is nothing, it is a ring, metallic ring, and force is applied on this ring, and we just say how much displacement, how much change in diameter is taking place. So in this metallic ring, force is applied, and we just measure how much change in diameter is taking place. When we apply force, and when the force is applied on the ring, it has certain thickness, right? So inside, on the inside wall of this probing ring, compressive strain is developed. It is under compressive stress. And outside is under tensile stress, and both are same in quantity. When both are same, then the signal we get, amplified signal or better signal. So there is a better option than the cantilever. So probing rings are used, and the output is displacement, input is force. Likewise, there is another very interesting device. That is board on tube. It is used in the pressure gauges. Now, it was invented by a French scientist in 1849, and Bourdon tube is a curved tube, right, of 270-degree angle. But here the external force is not applied on the Bourdon tube. On the Bourdon tube, I'll make a hollow section. It is used in the pressure gauge. So when this tube is pressurized, the cross-section area of this tube is elliptical. It is also a metallic tube, thin foil metallic tube. The cross-section area is elliptical. When this tube is pressurized, right, this elliptical section tends to become circular, first of all. There is a tendency of elliptical section to become circular, and on the free end, extension of this tube takes place. On the free end, extension of this tube takes place. Now we can have a relationship between the force in the tube and extension of the tube, right? With the suitable mechanical system, this extension can be transmitted to the center of the tube and ultimately to a needle or to a pointer. So this tube is specifically used for pressure measurement. Similarly, because they are classical mechanical devices for measurement, and as a mechanical engineer, we should know a little about these devices. That is why I am not going into the details of the analysis, because nowadays we are using simply transducers, right? But these devices are also important, and they have a number of applications. Only these devices are used, right? Now, second is bellows. There is third one, bellows. Now, bellows are there is a one piece. First of all, there is a one piece, and they can expand and contract in horizontal direction. Right? Like you must have seen in the backside of the harmonium. So in the backside of the harmonium is also their bellows. They are very flexible for the movement in X direction or in a particular direction. So these bellows are also used. The application can be same as in the case of Bourdon tube, or any type of pressure when it is coming here, right, on the diaphragm of the bellow will move in this direction. We can always relate force or the pressure as a function of displacement. Now, after bellows, one simple mechanical device which is used for measurement is diaphragm. Now on the diaphragm, suppose there is a flexible cloth. Let us take flexible cloth, right? When I poke a pen on the cloth will immediately deform. A projection will be formed here, right? If I put a pressure on the cloth, suppose there is a diaphragm. I will not say cloth; it is a diaphragm. So if we push a pressure on the diaphragm will bulge in this direction, in a particular direction, right? Now in this case, suppose I put a strain gauge. Strain gauges, I will be telling you details later on. But here if I put a strain gauge, what is going to happen with the strain gauge? So strain gauge will give the reading of strain developed here, right? And this strain I can always correlate with the pressure applied on the diaphragm, right? A spring can also be used as a mechanical sensor, a spring. As you know, I need not explain in details about the spring. It is always a function, force is a function of x, or F is equal to kx. So input is force and output is displacement. So a spring is also a mechanical detector, can be used as a mechanical detector. Manometer can also be used as a mechanical detector, because if it is let us talk about very popular U-tube type of manometer, where fluid is filled, certain fluid is filled, and all these parameters and all we will be discussing when I will discuss about the pressure measurement. I am just giving you an idea. Now this manometer is filled with some liquid, and liquid will find its limit by itself. Now if we exert pressure from this side, if the pressure is exerted from this side, definitely this side is atmospheric pressure, the lift will be lifted and a H will be developed, and H rho g will give the pressure difference, right? Now in some of the cases this H is very small, maybe 1 millimeter or 2 millimeter. H is a function of density of the fluid which is being used. H is a function of density of the fluid which is being used. So now I want to amplify this function. So in order to amplify this function, what I will do, I will make this leg inclined. So instead of making it vertical, I will make it like this. Once I make it like this, in that case, this H will be amplified. Now we can read from here with the inclined scale. And with the inclined scale, definitely the signal will. So this is how the output of the transducer can also be manipulated, and the objective is better reading, better measurement, and measurement which is error free. Now after manometer there is a pitot tube. Pitot tube also we will discuss in details in subsequent lectures. Pitot tube. Now pitot tube is used for converting velocity into the pressure, because in pitot tube there is, if you remember, there is a tip of the pitot tube, and from tip, suppose this is 0.1, this is 0.2, right? And at 0.1 there is a stagnation pressure, at 0.2 there is a static pressure, and difference of stagnation pressure, because the stagnation pressure is half V square, sorry, stagnation pressure is static pressure by rho plus half V square. So once we know the stagnation difference between stagnation pressure and static pressure, then half or rho V square. So V can always be calculated because density of the fluid is known to us, right? So there are certain scope of error in the measurement of pitot tube as well that we will discuss later on. But this is a very excellent device, and it is a passive transducer. It does not require any energy. So it is a passive transducer, and very comfortably we can, because in the aviation systems also nowadays, still nowadays, a lot of places this is a very reliable device for the velocity measurement, because those measuring instruments which are not consuming any energy, they are normally very reliable. So pitot tube is also a very reliable method of doing measurement of velocity. The last one is thermometer. Normal thermometer, that is liquid in glass thermometer. So liquid in glass thermometer also, I have amply discussed liquid in glass thermometer. So in liquid in glass thermometer also, the temperature, the change in temperature is converted into the change in the volume of the fluid which is in the bulb, and change in the volume of the fluid is also, again, it is converted into the displacement in a vertical tube, where it is a very thin or it's a very small diameter tube. So the signal is enlarged. So these are the typical mechanical detector for the measurement. But normally we go for the electrical transducers. We go for electrical transducers. The reason being, there are certain reasons for this. The reason is amplification can be done easily, because in electrical signals are easy to manipulate. Just simply put some power amplifier and you will get high magnitude signals, right? So that is the benefit of electrical transducer. Mechanical transducers also we can magnify the signals, but there are certain limitations. And in mechanical systems, it is always, friction losses and backlash, these type of scope of error is always there, right? And the mass inertia effect is minimum, because electrical systems, they have we can maintain very low mass moment of inertia. However, in the mechanical case, it is a little difficult. Friction is minimized, I have already explained. Recording is easy. Mechanical system, chart and pen type of recorder can be used. That can be one of the mechanical recording device. But nowadays, nobody is going for the device, because nowadays digital devices have come, very advanced digital devices and data acquisition systems have come. So all the signals, whatever form they are available, ultimately they are converted into the electrical signal, digitized and stored. And another benefit of this electrical output is it can be very easily used for the system control as well. Whatever coming, I'm talking about the feedback control. Suppose there is a system, right? And output is coming from the system. So there is a wall, suppose, right? And I want to maintain certain mass flow rate through this wall. Now here, with the help of a transducer, I will measure the mass flow rate. If it is exceeding the certain limit, immediately the feedback will go to the wall. It is actuated wall, and the wall will close. The mass flow rate will reduce. And it is when the mass flow rate is going below the prescribed limit, then this wall will open, the mass flow rate will increase. So these type of manipulations are easy. Even in mechanical systems also, for example, governing of hydro turbine and all, some mechanical feedback control systems are also there. But the applications are very limited. And for electrical signals, manipulation is easy, and feedback control is also easy when we have mechanical signals with us. Now, classification of transducers, active and passive transducers, I have already explained you. Primary and secondary transducer, primary transducers and secondary transducers mean if there is a transducer which come into contact with the measurand, that is the primary transducer. And sometimes the transducers are not in contact with the measurand. After one transducer, there is a sensor, and after sensor, the sensor is inbuilt in a transducer, then signals are going to the another transducer. So those type of arrangements are known as, are given in the second type of, and this type of arrangement is known as secondary type of arrangement of transducers. Digital and analog, I have already explained you, but we should not confuse that, we should not get confused with the fact that digital output of the system is error free. In fact, the most of the system which have very high accuracy have analog output. So even for the calibration purpose, or the primary systems which are used for the calibration purpose, right? So in those systems which are used for the calibration systems, the analog type of output is there. So analog type of output and digital type of output has got nothing to do with the error in measurement. But definitely, if you want very, very high accuracy, one should go for the analog type of system. And transducers also, there can be analog type of transducer, there can be a digital type of transducer. For example, this thermocouple, it is an analog type of transducer because signal is in millivolts, and we just simply put the voltmeter across the terminals and we get the output from the transducer. Input and output of the transducer. Input type of transducer is some phenomena is given, is input of the transducer, output is electrical signal. And when you reverse it, I mean, some electrical signals are going to the transducer, and on the other side some phenomena is taking place. That is known as output transducer. This is all for today. From the next class, we'll go for the selection of the transducers and the classification of the transducers. Thank you very much.